Okay, already is. Okay, so continuing where we left off yesterday. Okay, so before we get to the problem we left off on, just to kind of review what we did yesterday. So what we did yesterday was to tell whether something is continuous or not continuous, right? So if it's not continuous somewhere, it's either a hole, a vertical asymptote, or a jump, right? And then the two non-removable, vertical asymptote and jump, they could also be called essential as well. Okay. How did we tell if that was going to happen? Because they don't give us pictures a lot. They don't. Well, we take the left-sided limit. You take the right-sided limit at whatever number you're trying to test. If that equals the y value at that same x value, and they're all equal, then it's continuous. If one of those is off, it's not continuous. Okay, so that's pretty much what we were working on, what we were testing yesterday, last time we were here. Okay, so I think we left off at example 4B? Yep, 4B, yep. Okay, so this one was a little different. We're still testing continuity. We're still using, remember, when it says definition of continuity, that is this guy here. That's the definition. Testing those three things. Okay? Okay, so now the question says, what value would go there to make it continuous everywhere? So we got to figure out what value goes in a spot so that this thing has no discontinuities. It's continuous everywhere. Okay? So we have to figure out, first thing we have to figure out is what value are we going to check? Which value is the only time where continuity could be an issue? Well, first of all, I skipped the question. What type of discontinuity could this have? Could it have a hole?
No.
Could have a hole, right? The first one, yeah, could have a hole. Could it have a vertical asymptote? Yeah, for the same reason, right? For the same reason. Could it have jump?
Yes.
Right? Because it's a piecewise. So it could have all three. Or it could have one or the other. So we're not sure yet, right? So that's our first question is, where would it have a hole or discontinuity? Where could it have? What value? When x is what? 1, right? Because if I put 1 down here, it'd be 1 minus 1. And what if I put 1 up there? Yeah, so that would be 0, right? That would be 0 over 0. So it's going to have a hole. So the top guy is going to have a hole at 1. And that's where it switches, right? The only time I don't use this guy here is when it's not 1, when I'm plugging in anything other than 1, right? Okay, so we know it's going to have a hole at 1. The top guy is going to have a hole at 1, and there could be a jump at 1 as well. Okay? So it could be a hole. There's definitely a hole at 1. I don't know if there's jump. So what I have to do is check 1. That's all I have to check. Everything else is going to be okay, because every other number I would just plug in to the top guy, and I would get a number. It might be negative, it might be positive, it might be a decimal, it might be a fraction, it might be a whole number, but I would get something there, right? So 1 is the only value that I need to check. So what I'm going to do is I'm going to use the definition of continuity. So that's the limit as x approaches 1 from the right for h of x equals the limit as x approaches 1 from the left for h of x, and then that has to equal h of 1. If all of those guys are equal, we have something that's continuous at 1. If one of those guys is off, it's not continuous, and we don't want it to be continuous. They said it has to be continuous. Okay, so let's start with this guy here. How would I do that problem? So forget these guys for right now, just the one I circled. If you had that on a quiz or on a test, what would you do first? What would I do to solve the guy I just circled? Plug it in, right? Plug it in. Which one am I going to plug it into? The top? So the top, this guy, or am I going to plug it into the bottom? The bottom, right? I'm going to plug it into the bottom. So what happens? So where would I plug 1 in? Would I plug 1 in for A? No. I'd plug 1 in for X, but I don't have an X. So what's left? A. So that guy's A. Okay. What about from the left side? If I'm coming from the less than side, the negative side. Again, don't worry about these right now. Worry about this one. How would I do this one if it was on a test or a quiz? Plug it in. Which one would I plug it into? The top or the bottom? Bottom again, because it's not at 1. Or sorry, it is, sorry. So I plug it in at 1. Okay? So again, same situation, right? I get A. Okay? And then if I plug in this guy here, I would have to plug it into the bottom too, right? So that leaves us A equals A equals A. Well, we knew that before, right? So that doesn't really help us. Okay, so let's kind of think of it another way. So this will happen sometimes. Sometimes your way of thinking in the past will you'll run into a wall. It's okay. You just kind of reassess. We already know A is equal to A is equal to A. We already know that. Okay, so let's go back to here. Let's go back to here. Where am I coming from here? So when I'm finding limits, the limit of this, where am I coming from? The right side, which is the greater than side, right? So think of, I'm not at 1. We already tried 1. If I plugged it in, if I use just 1, it's not going to work, right? Because I get A equals A equals A. So which one could I also use if I'm approaching 1? If I'm approaching 1, which one could I, when I talk about 1 is which function could I use? If I'm approaching 1, because limit means approaching, right? So I'm approaching. So I'm not at 1. So I'm going to use this guy now. I'm going to use this guy, okay? Because I'm approaching 1. I'm not at 1. I'm approaching 1. So I'm going to use the top guy. So what happens when I plug in 1 to the top guy? Yeah, I get 0 to the 4th minus, or 1 to the 4th minus 1, and then I get 1 minus 1, which is 0 over 0, right? So that means we can do something with this. I'm not done with this, right? What the question is, what can we do? What can I do to this? So our options are, remember we had those, like the second lesson we had, you could factor, I could do conjugates, I could do common denominators. What was the other one I had? I think those were the big 3 that I had. So which one would best suit us for this green one, for this green guy? Factoring, right? It doesn't have a square root. It doesn't have any kind of a root. So I'm not going to use conjugates. It is a fraction, but it's not adding with another fraction. If it had something like this, then I would say, oh, okay, then let's use common denominators. So it's just one fraction. So let's try to factor this. It's a binomial over a binomial. Okay. So let's take a little detour here. So I have x to the 4th minus 1 over x minus 1. So the way we factor binomials is we ask 2 questions. The first question is there a GCF? So for this guy here, the top, is there a greatest common factor for that guy besides 1? Is there anything I can divide x to the 4th and negative 1 by besides 1? No. The second question I ask is it difference of squares? Is it a, right? Difference of squares means it fits this. I can rewrite it like that. So can I rewrite? What would go here? Good. What would go here? 1. If that's correct, if that's true, then it's difference of squares. So what would it factor to? It would factor to x squared plus 1 and x squared minus 1. Okay, so let's rewrite it like that. Here's the problem though. So now I try to plug in -1, and I get the same thing, right? If I try to plug in 1 like I did originally, I'd get 1 here, right? So this would be 2. But then this would be 0, right? So 2 times 0 is 0, and I'd still get 0 on the bottom. So I would still get 0 over 0 on the bottom. That means we have work left to be done. So let's look at where we're at. I have a binomial and a binomial. So ask the same questions. Do any of them have GCFs? No, besides 1. Are any of these guys here, in parentheses, difference of squares? So do any of those have that, right? Which one, the first binomial or the second? The second. The second binomial is also a difference of squares. X squared minus 1, because we can rewrite it as x squared. So that means it's going to be x plus 1 and x minus 1. So I'm going to change the second one to that. The first one has to stay because it's not difference of squares because it doesn't have a minus. The second one becomes x plus 1, x minus 1. And then I have x minus 1 on the bottom. Now when I do that, something will finally simplify. Right? So now this becomes x squared plus 1 times x plus 1 over 1. So now let's try to find the limit. So the limit as x approaches 1 for this guy, what do you get? You actually get an answer now. What do we get? 2 times 3? 6. We get 6. Oh, sorry. So I plug in 1 here, right? So that's 1 plus 1 is 2. Yeah. And then I plug in 1 there, so it'd be 2. Yeah, you're right. Yeah, sorry. I plugged in 2 here. I don't know why I plugged in 2 here. Yeah. So 1 plus 1 is 2, right? So 2 times 2, so 4.
Yeah. 10.
Okay. So now, let's do it again, but for this guy.
Oh, God.
It approaches 1, but from the left side, right? So I'm not at 1, I'm approaching 1. So which function would I use? The same one or A? Same one, right? And didn't I do all the hard stuff already? So when I plug in 1, I'm essentially just plugging it into the stuff I already did, right? And we already got an answer. Okay. The last one, I have no option. I have to plug it into the bottom. I have no option because that one is the y value at 1. It's not approaching 1, it's at 1, right? So what is that value? A. So that means 4 has to be A, right? A has to be 4. So that means if this guy right here was 4, it would be continuous everywhere. Any other number, you would have discontinuity at that value. Okay. There is a hole, though. There is a hole, like we said. There is a hole at 1, or at 4. There is a hole there, but it's continuous, so it's fine.
The hole there, but that's the other equation.
Yes, yes, that's the other equation.
Holes when 1.
So it doesn't affect continuity yet. Sometimes you have a hole, sometimes it's crazy. Sometimes you might have a hole, and then you have a dot, but it's the actual this. It's crazy. Sometimes you'll have that. It's rare, but you'll have a hole, and then sometimes you're used to having like a dot up there or something, or a dot down here or something like that. Sometimes the dot itself is actually like in the hole. Yes. It's rare, but it does happen sometimes. Sometimes it does happen. So there is a hole, but there's also a dot in there. Okay? All right, so the last one for continuity. The last thing is intermediate value theorem, which it's very easy. So here we go, last one. So this time we have to find A and B.
You guys want to find 0 pi
and b. Okay. It's got three pieces now. It's got three pieces. X plus 1, ax plus b, and 3x. So the first guy, that one doesn't have any discontinuity in itself. I could plug in any number for x, and I would always get a number, right? The second guy, same thing. I don't know what a and b are, but I would always get a number. The third guy, the same thing. They're all linear. They're all linear. They're all going to be straight lines. Straight lines in itself don't have any discontinuity. But where could I have discontinuity? Where they switch, right? Where they switch off. Where do they switch off? When do I switch off from yellow to green? At 1, right? Anything that's less than 1, I use yellow. Once I hit 1, I go to green. And then where else do I switch off? 2, right? Anything less than 2, that's in between 1 and 2, I use green. Anything 2 or above, I use the pink color, purple. Okay? So there's 2 areas I have to check. Not just 1 this time, there's 2 areas, there's 2 values I have to check. So let's do the first one. We said the first one was 1, right? So let's do that. The limit as x approaches 1 from the right for f of x has to be equal to the limit as x approaches 1 from the left for f of x, which is equal to f of 1. All of those have to be the same for it to be continuous at 1. So if I'm coming from the positive side of 1, I'm not at 1, right? I'm coming from over here. 4, 3, 2, getting closer and closer to 1. Which one of those would I use? The yellow, the green, or the pink? As I'm approaching 1 from the positive side. I heard all the colors. I heard all the colors. Okay, so here we go. So let's see. So I'm at 4 right now, right? So I'm at 4. Which one would I use if I'm at 4? Pink. I'm at 3, which one would I use? Still pink, right? Because that's bigger than 2. I'm at 2, which one would I use? I'm at 1.5. Now it switches to green, right? Because I'm here, right? 1.4, 1.3, 1.2, 1.1.
I was looking at green and I said yellow.
So I'd use this guy, right? This is the guy I would use. The green guy. Okay? So let's plug in 1 into the green guy. So we plug in 1 and we just get a plus b, right?
Oh, yeah, because you didn't say which number you started off.
Okay.
Okay, now I see.
Okay. So now I'm coming from the other side of 1, the less than side. -1, 0, 0.5, 0.6, 0.7. Which one am I going to use? Which color? Now it's yellow. Now it's yellow because everything less than 1, we use yellow. So I'm going to plug in 1 there. So if I plug in 1, it's 1 plus 1, which is 2. Now the last one, if I'm at 1, I'm not dancing around 1, I'm actually there. So if I'm at 1, which one would I use? The green, right? Because that has the equal 1, right? I already did that, right? What did I get? A plus b. So what do we get here? We get a plus b equals 2. A plus b has to equal 2. So whatever a is and whatever b is, when I add them together, I have to get 2 as an answer. So I'm going to put those to the side a little bit. I'm going to put those to the side. Okay? I'm going to put that to the side for right now.
I'm a firm believer in that.
Now I said I have to check continuity not only at 1, but at 2. So I'm going to check continuity at 2. So I'm going to do this again. But this time at 2. So 2 from the right for f of x. 2 from the left, f of x, f of 2. Okay, so now I'm approaching 2. I'm approaching 2 from the right side. So bigger than 5, 4, 3, 2.5, 2.4. Which one am I? What color am I?
3.
3? Oh, yes,
3x, right? 3x.
Oh, the number yellow. Yeah, Damien. The number J.
Good job, Damien.
3x. I know what you're saying.
Yeah.
He knows what he was saying.
I know what I speak Damien.
Damien. Do you not speak English then?
So here we go. Now 2 from the left. 2 from the left. So now I'm at, so let's start at -2. If I'm at -2, that's the yellow, right?
Yes.
-1, still yellow. 0, still yellow. 1, I'm not at yellow anymore, right? I'm at green. 1.5, 1.6, 1.7, still green, right? So green, A, plug in 2, right? So it's 2A plus B, right? Not A plus B, it's 2A plus B because I plugged it in 2 for X. So we know that has to equal 6, right? So now at 2, which color would I use at 2? The pink, right?
It's magenta.
Magenta, there you go. Fuchsia, whatever you want to call it. Pink, purple, whatever you want to call it. So that's 3x, right? 3 times 2, which is 6. So I know what equals 6. What has to equal 6? 2a plus b has to be 6. Remember that first one that I had, a plus b equals. So now I know that if I go 2 times a and then I add b, it has to be 6. How's that going to help me? Well, I'm going to bring them both in now. It will help me. Trust me, we'll get there. So let me write these down. A plus b equals 2 and 2a plus b equals 6, right? We said that.
A plus B equals 2A plus B.
Now, believe it or not, you know how to do this, but you learned it in math. You learned it in whenever you took math 1 and
Oh, so we forgot.
yeah, so you guys probably forgot about it. You guys probably forgot about it. But it's in there. It's deep in there. It's deep.
You can just set them, yeah.
That's the only one I remember.
Yeah. So there's 3 ways to do it.
My ass forgot to.
Graphing, substitution, elimination. I use elimination almost always because it's probably the easiest. Graphing, I would suggest doing that, especially if you don't have if you're able to use a calculator, you just graph them and where do they cross?
I'm going to set it equal.
But we can't use a calculator a lot in this class. Substitution you could use, but it's a lot more algebra.
That's the only one I remember.
Elimination is probably the easiest. Once we start doing this, you'll start being there. So eliminate. Eliminate means something goes away, right? What goes away? Well, A or B have to go away.
Damn.
Why?
Really picked good.
You're right. Why is B easier to make go away? What would I do to make B go away? Subtract them, right? I would subtract them. Well, in order to subtract them, I have to change one of them to negative. Doesn't matter if you do the top or the bottom, either one. So let's make the bottom -1. So to make that, I have to do it to everything because it's an equation, right? I can't just do something to one side of the equation. I got to do it to all. So the new one would be -2a minus b equals -6. The top guy doesn't need to change at all. Now when I add straight down, b's go away, right? How many a's would I have?
1A.
-1a, yep. And then what would I get 2 plus a -6? -4. What would a be? 4. We got half the answer now. What is b going to be? What would it be?
You just plug it in.
Plug it in, yeah. Either one works. What would be?
What would be B?
What would BB? What would BBB? BBB. -2. It would have to be -2. Because if I add 4 to what number would be +2? Well, the only way to make it +2 is to add a negative. So it would be -2. And you're done. So if A was 4, so if that middle guy was 4x minus 2, if this guy was 4x minus 2, it would be continuous everywhere. Okay?
Was it fun? Is it fun?
Yes. What is that? I can't even read that.
Intermediate value theorem.
Okay.
Lucky I can't read that because I would have said no.
Let's see what time we got. All right, so we got about 15 minutes. That's perfect time for intermediate value theorem. Okay.
I haven't finished.
Intermediate value theorem is one of those theorems that you don't use a lot, but when it does come up, you're like, how do you use that?
God damn it.
The idea is very easy. The idea is very easy.
I don't want to do x squared minus
I've never had a
minus cosine x.
Easy, but the hard part is remembering it all.
Yeah. So I've never had a student say it's a hard theorem. But sometimes when you're like, what do we use here? You kind of forget about it. So it's a good thing to put on your card when you're taking a test or a quiz. Okay? So you don't remember it. Okay. Intermediate value theorem says, okay, so if I'm here right now, right? If I'm here right now,
Yes.
and that door is over there.
Yes.
And let's say I got some painter's tape, some blue painter's tape, right? And I put blue painter's tape from this wall all the way through to that wall over there. So there's painter's tape on the ground. Blue painter's tape, right? If I had enough painter's tape, I'd do it, but I don't, right? So let's say I'm here right now. And you walk outside to blow your nose. When you come back in, I'm over here by the door. What had to have happened?
You were at every spot at once.
I had to have crossed the line. When did I do it? I don't know. But I had to have done it, right?
Did you step over it?
That's the intermediate value theorem. That's the intermediate value theorem. If I'm here now, and then I'm here, I had to have crossed every line in between here to there. Sometime. I could have crossed it twice. While you were gone blowing your nose, I could have gone once, twice, 3 times, 4 times, 5. I could have done that a million times, right?
No, not a million.
But not a million. Oh, that's right, not a million, right? It had to be a
Unless you're
million
going
and
like
one, right? It have to be a million and one.
Maybe odd.
There you go, right? So, how many times? It doesn't matter as long as we know you had to have done it at least once. Mhm.
We don't know you had to have done it because you could have sneaked out behind us and went
Behind us?
across
Jesus Christ.
here.
So,
And you went around it.
actually, so what I should have said, you're right. What I should have said is there's painter's tape all the way, continues through the football field, around the world, right? Around the world. There had to have been, I didn't have enough painter's tape from wall to wall, so I didn't do it from around the world. But yes, that's what I should have said. Around the whole world, I had to have crossed, right? Because you're right, I could have gone, because we live in a three-dimensional universe. So, right? So yeah, that's what that paragraph says, or that's only one sentence. That long sentence says. Yeah.
Dude, what a run-on sentence.
So what we have to do, so there's going to ask you 2 questions. They're going to ask you A, to prove it. So how do we prove it? Well, where are you here? Show me where you're at here, right? What y value are you here? What y value are you at B? And if you've crossed the line, then you're good, right? Because this is a y equals situation. Same thing, and the other thing they'll ask you is what 0? They'll be like, is there a 0 in between from dot to dot? So they'll say like, here's your first dot over here. Here's your second dot over here. Is there at least one 0 in between C and D, point C and D? Yeah, right, because I'm below the x-axis here. I'm above the x-axis here. I had to have crossed the x-axis at least once. Okay? Okay, so here we go. Let's try example 1 for that. So the function is f of x, so this is the function here. The interval is from 0 to 1, so a really tiny little interval. So what they're asking is, does it have a 0 in between there? So in other words, did I cross the x-axis somewhere between 0 and 1? Well, the answer is find out where you were at the start, find out where you were at the end, and we can tell from there. So how do I figure out what y value I was at 0? What do I need to do to figure out what y value goes with 0?
Plug in 0.
Plug in 0. So let's do it.
What are we gonna do?
Oops. Minus 2. So 0 plus 0 minus 2 equals negative 2. So was I below or above the x-axis at 0? Below. Slightly below. Below. So let's see, where was I at above? Or sorry, where was I at 1? Was I above or was I still below?
Yes.
1 plus 3 minus 2, positive 2.
I don't know, man. 4 minus 2, I think is
So at 0,
1.
I was at negative 2, below the x-axis. Let me draw a little picture here. So at 0, I was at negative 2. At 1, I was above the x-axis. To connect those two blue dots, I have to cross the x-axis. How many times? I don't know. But at least once. So we showed it. That's how you show it.
Words.
Okay?
Oh,
So in words, yes. So let's explain in words. Let me see my notes from last year, exactly what I wrote.
then numbers.
F of 0.
Hang on.
What did I put last year? Where are we at? No, wrong one. Continuity, here we go. All right, so.
Boom.
Okay, so we put IVT or intermediate value theorem. You can put IVT, I don't care. You can abbreviate, that's okay with me. IVT applies because what should we put? Because we started at 0, negative 2 and ended at 1, 2. Therefore, we crossed the x-axis at least once. Okay. So let's try number 2. Where were we at 0? When x was 0, where were we at? 0 squared minus 0 minus cosine of 0. Well, 0 is 0 minus 0. Cosine of 0 is 1, because that's where cosine starts. Negative 1, right? So I'm at 0, negative 1, below the x-axis. And where am I at pi? Pi squared minus pi minus cosine of pi. Now I don't care what the actual number is. Pi squared, 3.14 times 3.14. I don't care what the number actually is. I just want to know if it's positive or negative, right? So pi squared is going to be 10 or 11, something like that. Minus pi, which is minus 3.14. So we're kind of at 7-ish. What is cosine of pi? I believe it's 0.
The sign of pi is 1.
So if I'm subtracting these two guys, right? If I'm subtracting these two guys, am I going to end up with a positive number or a negative number? Positive, right? Positive. I can approximate it in my head, but I can't use a calculator, so the best I can do is approximate it in my head. It's going to be like, it's going to be between 8 and 9, I think. Okay? So intermediate theorem will apply again. IVT applies because, I'm going to write it a little differently since I don't know the exact coordinate for the second one. I'm going to say because f of x had to have crossed the x-axis at least once. IVT applies because f of x had to have crossed the x-axis at least once. I didn't put the actual coordinates because I don't know what the second one is. Yeah.
Why do you have to write it out?
Just,
Because they hate us.
yeah, just to say, just to kind of, so the way I was taught was if I just had the math, we understand it. Calculus teachers, calculus student understands it. If you put that on a test, I would understand it. But you're just trying to,
Show your understanding.
show your understanding to somebody who's not a calculus student or a calculus teacher, but maybe someone who is a math student or a math teacher who doesn't know calculus. So you're just trying to explain them a little better. Do you have to do it all the time? No. 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 Okay. The only other one that we have is the back one, number 3, right? What I want you to do is I want you to change this one a little bit. Change it to, change this 0. That 0 there, I don't want a 0. I want a positive 4. So this is what it's going to say.
I know, this is really good.
F of c equals 4. So when it says f of c, that means where is that line? Where is that line, right? 1 and 2, the line was at the x-axis, right? Now the line moved up to positive 4. So now we got to show, did it cross the line, which is at positive 4? So positive 4 is here, right? The blue line now has moved up here. So is the blue line, now does it cross the blue line at least once? That's all it means. Before it was the x-axis, right? Because it was 0, right? So let's figure out where is it at, so the interval is from 0 to 3. So at 0, it's going to be 0 squared minus 6 times 0 plus 8, right? All of these guys are going to go away. You just get 8. So 0, 8. Okay, what about 3? 3 squared minus 6 times 3 plus 8. So 9 minus 18 plus 8. Negative 9 plus 8. Negative 1. So that would be here. I should use a different color. So to connect the red dots, do I have to cross the blue line somewhere?
Probably.
Yes. At least once.
Probably.
Okay. That's the IVT. That's intermediate value theorem. This is not, I've never seen this on a multiple, I've never seen it on a free response question. I've seen it, like, it's one of those questions that's like one question on a test. So is it important? Yeah, because I want to get that question right. Is it going to kill you? No. So this is the thing I usually tell students to write on your card to remind yourself, just in case you see it on the test. That kind of thing. Okay? All right, and that's the chapter. We're done with the chapter now.
Oh, shoot.
Okay, so what we're going to do tomorrow is you're going to work on the practice that I gave you. Everyone should have that. And then Friday, we'll go over that if you guys have any questions, and I will give you the review, the chapter review.
What? Okay, what?
Yes.